Let's take a look at LeetCode question 57, insert interval. And this is a great question because we start getting exposed to intervals and working with those. Let's have a look at the question. You are given an array of non-overlapping intervals, where intervals I is an array itself. So we have an array of arrays, or an array of intervals, and each interval has a start number and an end number, and they represent the start and the end of the ith interval. And intervals is sorted, and that's important, in ascending order by start. So whatever the smallest starting number is, that will be the position in the array. You are also given an interval, new interval. So we're giving a list of existing intervals, an array of arrays, and then one new interval that represents the start and the end of another interval. And we need to insert that new interval into the existing intervals such that it's still sorted and it does not have any overlapping intervals. Now, if they do overlap, it says we need to merge the overlapping intervals if necessary. And then we need to return the intervals after insertion. So I think we should just have a look at an example here, because the example sort of clarifies what that means. So basically, in this example here, we have this array of intervals. So the first interval is 1 to 3, the second interval is 6 to 9. And then we have this new interval, 2 to 5. Now, there's three real cases when inserting an interval. So basically, imagine that this number was, say, -1 to 0. Basically, you could just take that number, and since the 0, the last number in the new interval, is smaller than the smallest number in the existing intervals, you can pretty much just take that -1 to 0 interval, put it at the start, and then just sort of append all the existing intervals after that. So that's one case. Another case we would have is, so let's just say this was the interval 10 to 11. Well, in that case, the starting element of the new interval is bigger than the last element's final interval there. And because everything's sorted, you could just take all of the existing intervals and then tack on the last one. But this case here, this is the case we got an overlap, and it's an overlap because we can see that this number 2 is in this interval here, and basically what we'd want to do in that case is we'll take the start number, the smallest number, which is 1, so 1's bigger than the 2 here, and then we want to get the largest number, which will be the 5 here. And then we'll end up with the interval, then we'll get rid of this interval here, and then we'll merge into 1 and 5, which we have here, and then we'll also have our 6 and 9 here. So that's one case, and in this case we only had to loop through one of these elements to see that. However, if you look at this second example where we've got the interval 4 to 8, we can see that 4 to 8 is between 3 to 5, 6 and 7, and 8 and 10. So we'd need to return a output where the first is 3 and then the final one is 10. So just a note, that's sort of inclusive, so we can't have any overlap where the last number is equal to the first number of the next. It's all overlap, so they'll just sort of merge all into one array there. And another case you could have is, let's say you had the interval, say 4 to 5 for this first example. Well, then we'll sort of need to, there's no overlap, but it's not before or after, so we'll just need to sort of put it in the middle there, and they'll actually get taken care of for us while we're from our other cases. First thing we want to do is we need to return all of our intervals. So let's have a variable, we'll call it new intervals, and the intervals, each interval is a number array, and it's going to be an array of intervals. So the new intervals we're going to initialize to an empty array here. And then we're going to need to loop through everything. And then after we loop through everything, we're going to want to return the new intervals. So that'll be the last thing we do there. But in between that, we're going to need to loop through all of our intervals. So basically, I'm going to have this for loop, and I'm going to have an index in this for loop because I'm going to need to use the index to be able to work out which intervals should be included depending on the index. And we'll see that shortly. But basically, we're just creating a regular for loop here, looping through our array of intervals, which are arrays themselves. So an array of number arrays we're looping through. And then I'm just going to have this interval variable here. And since we're using the old-fashioned for loop, we can just access that by the ith element there to get the individual interval. Now, what we want to do is we want to address those three cases that we've talked about. Basically, that we're going to have an if, an else if, and an else. And the first condition in the first if is basically we've been giving a new interval. So if that new interval, if the end value, which is in the first position, so the 0th position is the starting value, the first position is the ending value because they come in pairs. If that is going to be less than the interval starting position, that means we can just go ahead and we can take the new intervals and we can just go ahead and we can push that new interval. And basically, since the new interval, the last value in the new interval is less than the starting value of the existing intervals, that means we can just more or less append the new interval at the start and then just sort of give back all of the existing intervals. So we can just say, and we can put this in a variable itself to make things less confusing. We're going to have the remaining intervals, and that's going to be equal to the intervals. And then if we just splice out whatever iteration we are on the loop here, and then we can take the intervals dot length minus I here. So this takes care not just before, but also, you know, if you get to a stage where it's in between or something like that. And then we can just go ahead and we can just return the new intervals and then also the remaining intervals. So just to sort of recap this section here, if we're thinking in the first iteration, meaning that the new interval is smaller than the very first iteration interval, what we'll do is we'll just sort of, we need to splice out, you know, whatever we're on. But it could be the case that it's a interval in the middle sort of thing. So let's say, you know, you've already passed one interval. Well, you know, you'd keep that, or you'd get rid of that, and then you'd keep the remaining ones after that. So then we have this else if here. So else if we had the case that the new interval is greater than the interval in the ending position there. So that's sort of the other way on. If the starting position of the new interval is greater than the first position, what we'll do is would say, okay, well, we'll take the new intervals, we'll push on the interval, and then basically, you know, we've got our new intervals here. We've pushed the new intervals to the end here. And basically these other cases will sort of put the other intervals in as needed sort of thing. So if the new interval isn't before the existing intervals and it's not after the existing intervals, there must be some sort of overlap between them. So we can have a new interval here, and we can actually overwrite this value here because we're going to want to do something like this where we have the new intervals and then we push on the new interval here. So that means we can overwrite the new interval variable, and then we can say, well, we know we want the minimum of the starting and the current interval and the maximum of the ending new or current interval. So we can just say something like this. For the smallest value, we take the minimum using the math library based on the current interval or the new interval starting value. And then the largest value, or the end of the interval, will be the maximum value of the same thing, but in the ending position here. So we can just do something like this here. And we can put on a semicolon there. And I might just move this up so it's all on one screen here. So basically what we've done here is we've handled the three cases that we needed to handle. If the new interval, if it's less than the current interval, we just go ahead and we push it to the start of the new intervals, and then everything else after that's going to be bigger than that, so we can just take everything else after that and tack that on. And we do that with this splice method, and just some array destructuring. Actually, I don't know if it's destructuring, using the spread operator. And then else if, you know, it's bigger, then we can just simply push. Otherwise, we need to merge the intervals. Now, it could be the case that you need to merge multiple intervals, and then when you go to the next iteration of the for loop, this new interval has been overwritten. So then when you go to the next iteration, it will take that into account as well. And likewise, you might not get something right at the start, right at the beginning, right at the end. So when I explained it, I talked about it being at the right at the start or right at the end here. But this can also work for the in-between cases. So one of the intervals that isn't right at the start, right at the end, but you've got something in between. This would be true for that as well, because we got this for loop. Let's say the first interval, you know, we keep that sort of thing. And then it's one of the, let's say we had 3 intervals, and then the first interval we kept, and then we want to sort of put in the new interval after that. Well, we've already gone through that for loop, we've already pushed that to the array from another one of these cases, and then we could sort of push that in there. So it all gets handled like that. And if I go ahead and submit this code here, we can see that this beats 72%, so that's pretty good.